Welcome to iLecture Online, and here's a new topic for you in physics, namely moment of inertia. Now, what is moment of inertia? Well, when we think of the term inertia, we think about the difficulty of moving things. So in normal life, when you look at something that's difficult to move, you think of something that's very big. So the bigger the mass, the more difficult it is for it to move, so it has more inertia. Once it's moving, it's harder to stop. Once it's stopped, it's harder to get it to move. Well, the moment of inertia has to do with things that are rotating. We're dealing with rotational motion here. And what makes an object more difficult to rotate? So there it becomes not just a function of its mass, but also where that mass is located, where it's oriented. So for example, if we have, let's say, a small thin bar, let's say that it's so thin that we can ignore its mass, and then we suspend an object next to it or on the end of it, so with mass m, and let's say that this has the ability to rotate like so, and let's say that this has the length r for radius of motion, then the moment of inertia, which we use the variable I for, I is equal to m times r squared. So notice there's two things here that make up the moment of inertia. Its mass, because the bigger the mass, the more moment of inertia it has, but also depends upon how far the mass is located away from the point of rotation, the center of rotation. And you can see that since r is squared, the distance where the mass is located from the point of rotation is the most important part of this. So, for example, if I had something that looked like this, let me write over here, something like this, that where I have twice the mass as before, 2m, and the distance still is r, so this is still the radial distance, like so, and let's say that this thing can rotate. So now we have twice the mass. What is the moment of inertia now? If this was the initial moment of inertia, what is the moment of inertia now? So I is now equal to, since the mass is doubled, it would now be twice the original moment of inertia, I initial. But on the other hand, if I had the same mass, but now I make the distance twice as long as before, and I use the same mass at the end here, so now r is 2r. How would that change the moment of inertia this time? Well, since r is squared, 2r squared is 4r squared, so then we can say that the moment of inertia here, I, is equal to 4 times the original moment of inertia. So this is to help you illustrate what moment of inertia is. It is the quantity or the entity that makes it difficult for the object to be rotated. The bigger the moment of inertia, the more difficult it is to get it to rotate, the more effort it will take, and we'll talk a little bit more how that effort is expressed in terms of physics. But the general equation always is that the moment of inertia of any object is mr squared. Of course, this only applies when all of the mass is located the distance r away from the point of rotation. If the mass is distributed in a different way, then we need to figure out what the moment of inertia is for that. But that comes later. We'll start out with this simple concept. So when all the mass is located a distance r away from the point of rotation, the moment of inertia is the mass times the radius squared. And understanding that if we double the mass, we double the moment of inertia, because the moment of inertia is a function of the mass to the first power. However, if we double the radius, then the moment of inertia is quadrupled, because the moment of inertia is a function of the radius squared. So if we double the radius, since it's squared, it'll be 4 times the moment of inertia. So that's a general introduction of the concept of moment of inertia. Now let's go talk about how we can actually find the moment of inertia of various objects, where the mass is not all located at the very end, where the mass is also distributed in different ways. And we'll look at that in just a moment. Okay. Video number 1, on to video number 2.